Hello and welcome to our ASP.NET Session-Store demo. Let's quickly look at the benefits of such a configuration. Consider a situation where you have multiple web servers running the same web application while the web application is being ported from one web server to another. Consider another situation where you have a large web application that is broken down into multiple modules, and these modules need to seamlessly interact with each other. In other words, they need to share session data between each other. Take a web application as an example where the application stores a lot of session data in the memory heap itself. Obviously, you're looking at reducing the web application memory footprint. You could use the Session-Store configuration for that. You could have an enterprise application that is deployed on multiple data centers, and you want to have a seamless user experience across both. You could have this kind of a configuration for flexibility, scalability, high availability, etc. Let's look at the various scenarios that we are going to show in this demo. Scenario 1, very simple. You have one IaaS web server with one web application interacting with the IMDG, the in-memory data grid, storing session data in there, retrieving from there. Very simple. Scenario number 2 is a little bit more advanced, where you have a cluster of IaaS servers, both of them serving the same web application. It's being fronted by an Apache cluster manager, and both of these applications that are storing, retrieving, updating session data in and from the in-memory data grid. Scenario 3, where you have multiple applications on multiple IaaS web servers that are storing and retrieving HTTP session data from the in-memory data grid. The final scenario is going to be where you have a multi-data center deployment and you're sharing the session store, the session data, across the WAN over to the various data centers between the applications deployed on these data centers. So a region like US, RU, DE, we could be running web applications on these data centers, and these could be sharing the session data information across the various data centers, which is achieved obviously via a combination of the WAN gateway and our XAP platform. Let's look at the demo for scenario 1. We have one IaaS server running one web application that is going to interact with the IMDG, and it's going to store all HTTP session data in there. I'm on the IaaS Manager console. We have one website, MyXAP2App website. This is running a web application called MyXAP2App. It's running on port 60, so let's browse the application. We see the app MyXAP App 2. We see that it has a session ID that it created, and currently it has no session data stored. Let's store something. Then let's go ahead and confirm that this was stored in the IMDG. Let's go to the Management console. We go to the Statistics window, and we see the insert has happened. Let's go to Types. We see session data entry has occurred. There's one instance count. We're going to query this, and we're going to confirm that the session ID is the same as what we have in the other window. This is the session ID. It's the same as over here. What happens if this web application goes down? Let's shut down this web server. Let's try to browse to the site. We're not able to. Let's go ahead and restart this. Let's browse to the same application again. We see that we connect to the same application, the same session ID, and we also retrieve the session data from the IMDG. That's our scenario number 1. Let's look at scenario number 2. We have Apache Cluster Manager round-robining requests to IaaS web servers. These are the two IaaS web servers that house the same web application that is interacting with the in-memory data grid and storing and retrieving HTTP session data from there. The website in question is MyXAP1 app website. As you can see, the two instances are listening on port 70 and port 90. This is going to be fronted by Apache Cluster. This is the URL for that. We see the MyXAP app 1 that we spoke of. We see right now the cluster manager routed the request to port 90. The next request goes over to port 70, so this is acting as a cluster. Right now there is no session data involved. Let's put in some session data here. The next request goes over to port 70. This is a second instance of the application, and you can see it retrieved the session data from the IMDG. Let's go ahead and confirm that. In the statistics window, you can see that the write has happened, the read has happened. The session data entry variable is there. We query this and we confirm that the session ID is the same. This is the session ID from this application. From port 70, we could also store another session data. The next time it retrieves it, it's from port 90, and we see the same session data is retrieved. Let's stop this website. We cannot browse to the website right now because we have stopped it. Now let's go ahead and start the website. Try to browse to the same URL again. We go to port 90, the same session data is still available. That's our scenario number 2. Let's look at scenario number 3. We have the IMDG. There are two IIS web applications, App A and App B. App A is a clustered web application. App B is a standalone web application. App A is the clustered web application that we just saw. App B is the standalone web application that we saw in scenario number 1. All of these applications are going to interact with IMDG. For example, the clustered web application is going to store data in the IMDG, and the application B is going to be able to retrieve this web session data from the IMDG. This was a clustered web application. Port number 70, there's no data stored. Let's make another request. Port number 90, clustered web application, there's no data in here. Second application, it was running on port number 60, MyZap App 2. The other app is called MyZap App 1, running on port 60, totally different session ID than here, very different session ID. No data is stored in the session. Let's go ahead and store data from here. Let's say last name Ronnie. We have stored that data here. Right now we retrieve the request from port 70. Let's make another request. Goes to port 90. Same session data is available here. Let's go over to port 60. There's no data available here because this has its own session. So now let's try to browse the session from the other application. This is the same session ID that XAP App 1 had created. This session ID. We pass it a session ID equals that session ID name, and immediately it picks up the session data from the IMDG. Last name equals Ronnie. Let's go ahead and look at the data in the management console. Let's query the space. As you can see, there are two session IDs created. This session ID is the same that we've been seeing so far, which is this session ID of MyZap App 1. The next session ID belongs to Zap 2, this one. This is the same as this session ID. This is how you can store and propagate session data between various applications using XAP. Let's go to scenario number 4. What we have here are 3 different data centers located in 3 different regions. They could be in 3 different countries altogether. Let's consider data center number 1 in US, data center number 2 in RU, and 3 in DE. IMDG is installed and configured in each of these data centers. 3 different instances of IMDG communicate between each other using the WAN gateway feature. Each data center could have a standalone IIS web server with a standalone web application, or it could have a clustered web application. Let's consider IIS cluster in US data center that's interacting with the IMDG, storing and retrieving data from the HTTP session in and from the IMDG. Instantaneously, that data that this IIS cluster stored in the IMDG is replicated over to RU and DE using our WAN gateway feature. So any application that is in RU or DE could access exactly the same session data that is available to the application in the data center US. Let's proceed with the demo. As we discussed, we have deployed 3 different regions, US, RU, and DE. We have deployed 3 instances of IMDG in these 3 different data centers, and these 3 regions are communicating between each other using the WAN gateway feature. So any application writing any session data into the IMDG itself in US will immediately be propagated across to DE and RU, and vice versa. This is the GSUI view. Let's look at it from the web UI view. Same representation. We have our statistics window. Since the gateways are active, we can see the inbound and outbound activities here. We have WAN space DE, RU, and US. Now let's store some data. This is a standalone application, MyXAP App 2, running on port 60. It is listening on WAN space US. We also have our clustered application, MyXAP App 1, running on port 90 and port 70, listening on WAN space DE. Let's store some data here. We store data in WAN space DE. This session data is immediately propagated across to WAN space US and RU. Let's go ahead and confirm that. This was our application. Let's reach out to that session ID. And we see that the value is being retrieved from WAN space US, DE, and RU. The same session data is available everywhere. Let's look at the management console. We have our WAN space DE, RU, and US. Statistics window immediately tells us the reads, writes, etc. that have happened in the US region. Let's look at it in DE. Same thing, immediately propagated across. Same with the RU. Let's look at types as we did before. Session data entry. We're going to query that. This was the session we're using. Let's look at gateways. We see RU has activity from US and DE. Graphically, you can look at the same. For DE, you will see inbound activities as an example from US and RU. You'll see the statistics window, update, reads, etc. Let's look at the GSUI. Go to the space browser. Objects counts over here. WAN space US has 1, DE has 1, RU has 1. We can query each one of these. Querying WAN space US. We see the data, session ID, session items, etc. Let's query WAN space DE. Same thing here as well. Session ID and session items available here. Finally, let's query RU. The data has propagated across all the regions. This is how simple it is to set up 3 regions communicating between each other using the WAN gateway feature. The session data stored in one region propagated across to the 2 other regions immediately. So any application that stores session data in one region can immediately have that application session data accessible by any other application running in either one of the other regions.